Welcome to the 8th part of Thermal Properties of Matter. In this part, you will learn about latent heat. Latent heat. Certain amount of heat energy is transferred between a substance and its surroundings when it undergoes a change of state. And the amount of heat per unit mass transferred during change of state of the substance is called latent heat of the substance for the process. For example, if heat is added to a given quantity of ice at minus 10 degrees Celsius, the temperature of ice increases until it reaches its melting point, that is 0 degrees Celsius. And at this temperature, the addition of more heat doesn't increase the temperature, but causes the ice to melt or changes its state. And once the entire ice melts, adding more heat will cause the temperature of water to rise. A similar situation occurs during liquid gas change of state at the boiling point. Adding more heat to boiling water causes vaporization without increase in temperature. The heat required during a change of state depends upon the heat of transformation and the mass of substance undergoing the change of state. If m mass of a substance undergoes a change from one state to other, then the quantity of heat required will be Q equals to m into L, where L is the latent heat and is a characteristic of the substance, and its SI unit is joule per kilogram, and its value also depends on the pressure. The latent heat for a solid liquid state change is the latent heat of fusion, denoted by capital L with a subscript F. And for a liquid gas state change is the latent heat of vaporization, denoted by L with subscript V. These are oftenly referred as heat of fusion or heat of vaporization. Here is a plot of temperature versus heat energy for the given quantity of water. And you can see from the graph the solid phase change, then the liquid phase, melting point, then again the phase change, boiling point, and then gaseous phase. When heat is added or removed during a change of state, the temperature remains constant. The slopes of the phase lines are not all the same, which indicates that specific heats of the various states are not equal. For water, latent heat of fusion and vaporization are 3.3 into 10 raised to power 5 joule per kilogram and 22.6 into 10 raised to power 5 joule per kilogram respectively. That is 3.33 into 10 raised to power 5 joule of heat is needed to melt 1 kilogram of ice at 0 degrees Celsius, and 22.6 into 10 raised to power 5 joule of heat is needed to convert 1 kilogram of water to steam at 100 degrees Celsius. So steam at 100 degrees Celsius carries 22.6 into 10 raised to power 5 joule per kilogram more heat than water at 100 degrees Celsius. And that's why burns from steam are usually more serious than that from the boiling water. Here is example 11.4 of your NCERT. When 0.15 kilogram of ice at 0 degrees Celsius is mixed with 0.3 kilogram of water at 50 degrees Celsius in a container, the resulting temperature is 6.7 degrees Celsius, and you have to find out the heat of fusion of ice. You know that heat lost by water will be ms delta theta, or change in temperature you can say. By putting the values, you will get it as 54376.14 joule. Heat required to melt ice is M2 into LF, and by putting the value, you will get the value. Now heat required to raise temperature of ice water to final temperature will be M1 SW into delta theta, and by putting all the values you will get 4206.93 joules. And you know that heat lost must be equals to heat gained. So by equating the terms, you will get the latent heat of fusion of ice, and that will be 3.34 into 10 to the power 5 joule per kilogram. Heat transfer. Heat is a energy transfer from one system to another, or from one part of a system to another part, arising due to the temperature difference. Three distinct modes of heat transfer are conduction, convection, and radiations. Conduction is a mechanism of transfer of heat between two adjacent parts of a body because of their temperature difference. Suppose one end of a metallic rod is put in a flame. The other end of the rod will soon be so hot that you cannot hold it by your bare hands. Here heat transfer takes place by conduction from the hot end of the rod through its different parts to the other end. Convection is a mode of heat transfer by actual motion of matter, and it is possible only in fluids. Conduction and convection require some material as a transport medium. These modes of heat transfer cannot operate between bodies separated by a distance in vacuum. But the Earth does receive heat from the sun across a huge distance, and we quickly feel the warmth of the fire nearby, even though air conducts poorly and before convection can set in. This third mechanism of heat transfer needs no medium and is called radiation. And the energy so radiated by electromagnetic waves is called radiant energy.